What's going on, everybody? Mr. Diamond, and as you may notice, I have forgotten my webcam at home today, which means most of these videos, or these next couple, may have no picture of me, unfortunately. I know how will you possibly survive without my beautiful visage gazing upon you, but I think we will all be able to make it without it, just this one time. So our last section of notes that we're here to look at is acid naming, and for this class, acids are probably the easiest to identify, so to figure out what they are, but can be the hardest to actually solve for. To identify them, acids either have an H as their formula beginning, so it's like H2SO4, HCl, H3P, any of those would be examples of acids. They have H at the very beginning. Or for their names, they just have acid at the end. Their name literally has acid in it. So it's pretty clear to find them, but then actually solving their problem can get a little tricky. So there are three actually different ways to name acids, and they each depend on what the ending of the anion or the second piece is. They always have H's as their first piece, and they have H's equal to their anion charge. So if the negative piece has a -1 charge, then there's going to be one H attached to it. If it has a -2, there's going to be two H's. If it has a -3, there's three H's. There's not really an example I can think of off the top of my head that would very commonly have four, but it would have four H's, and I guess if there was exactly boron, you would have a 5 charge, or 5 H's out of the front. Now, as a reminder, the endings we've talked about before are ides and ates and ites. Now, in class, you may only be familiar with ides and ates. Ides, we said, almost always refer to single elements. Ates refer to polyatomic. Ites also refer to polyatomics. They are the modified version of 8 polyatomics. You can reduce the number of O's that are found in them by changing the ending to ite. There's a little mnemonic that I'll give you at the end of this that may hopefully at least help you figure out some tips on remembering the rules associated with each of these names. So first, ide endings usually meant a single element. If the non-hydrogen part would normally be named with an ide, so if it was chlorine, we would have called that chloride. If it was bromine, we would have called that bromide. Nitrogen, we'd call that nitride. But there are a couple polyatomics, so like the example down here, CN would be cyanide. We change it and we call it we would call the acid associated with it hydroblankic acid, and in that blank we would insert what the element is. So for HCl, Cl would be called chloride, and so we would take that chlor part, get rid of the ide ending, and shove it into this part of the name right here. It would be hydrochloric acid. I believe when Mr. Zuspin taught this, he used to say that the way you could remember it is that hydro means ain't got no O's, and that should work for most of the examples. There's a very few very weird ones that wouldn't work with, specifically the polyatomics. But in the case hydroblankic acid, basically always means ain't got no O's. So HCl, there are no O's in this acid, so we use hydro. And then we change the ending to ic, and we add acid at the end. And notice we don't have anything about the hydrogen there because seeing acid in the name tells us that it's got to be an acid and that hydrogen has to be the first piece. So down here we've got HCN. CN is cyanide, so that also ends in an IDE. So it would also get named, it ain't got no O's, as hydrocyanic acid. You change that ide to an ic and add acid to the end. Okay, next type of ending is one that has ates. Ates means there are polyatomics involved. And we name it as a blankic acid, no hydro, because again, hydro means ain't got no O's. So a blankic acid means that it is an 8 ending, and it means you're dealing with a polyatomic. So H2SO4. SO4 is sulfate. So H2SO4 would be, we change the 8 ending to an ic, and it would be sulfic acid. But the more common way that we refer to that would actually be sulfuric acid. And you've probably heard of that before. It comes up a lot in pop culture. And then HClO3. ClO3 is chlorate. We change that ending to an ic and add acid, so it would be chloric acid, would be HClO3. And then we have ite endings finally. That means it was a modified polyatomic. The name we use for those is us acids. Instead of changing it to an 8 or the 8s to an ick, we change the ites to an us, an O-U-S ending. So here, H2SO3, notice if I flip back to the previous one, H2SO4 had one more O's, so it was sulfate. This has one less O, so it is sulfite. We would name it as sulfus acid, or again, more commonly for this one would be sulfurous acid, as H2SO3. And again, notice their number of H's is just equal to the charge. Sulfate and sulfite both have a -2, so there's 2 H's. And then over here we have HClO2. That is, again, if I click back and forth between the slides, ClO3 was chlorate, ClO2 would be chlorite, so it would be chlorus acid. If you want to, after these notes or as these notes go up, the whole PowerPoint will be going up, and you'll have the access to those to kind of check any of your previous parts. There is also extra practice of every single one of these, including these acid naming examples right there. So I'm not going to do these examples because I want you to be able to go back and use them as extra practice whenever you are trying to solve for or trying to practice review for your test. So that is all for this video. In the meantime, if you have any questions, please shoot me an email. Otherwise, this is Mr. Diamond signing off. Have a great rest of your day, everybody.